All right, what up, what up, what up, what up? You already know what to do. It's your boy B-Phil, and it's time to learn something new. So today, we're gonna go ahead and take a deeper dive into Langfuse. And in my previous video, we went ahead and showed just very simple tracing. Today, we're gonna go through the dashboard, we're gonna look at some generations, and we're gonna look at some evaluations and how you can add those to data sets and get those sweet scores. So if this is what you're looking for, go ahead and stay tuned, and let's get right into it. So today we're going to be talking about Langfuse, and this is an open source LLM engineering platform. Quick pause. If you're actually a builder and you're looking to join another group of builders that are actually trying to build real things, if this is not you, don't worry. Join the school group or school community in the description below and just go ahead and introduce yourself. But if you're anyone else, just go ahead and join my Calendly. I'll give you that technical support that you need. Let's get back to it. So Langfuse is the open source LLM engineering platform, and it offers you traces, evals, prompt management, and metrics to debug and improve your LLM applications. So let's just go ahead and look at what that looks like on the dashboard. So when you go ahead and go to the dashboard, you're greeted with all of these nice metrics. You can go through these yourself, but they're pretty good for at a glance metrics. What we want to focus on is the meat of this actual application, and that is the traces. So if you're familiar with logging, if you're not, you have things where you can do spans, and then you can have traces in those spans, and inside of those traces, you can have different generations here. So typically you might have like calls or logging, things of that nature in a traditional application, but since this is an LLM application, we're going to have all the different types of operations inside of a trace that can happen with an LLM. So let's go ahead and see what that looks like here. So we have trace details here, and this one is for an upward value evaluator. And this looks like this is evaluations, and we're going to talk about that, but what I actually want to show you is something like an extraction task. So here you can see on this particular screen, what we're doing is we're doing some type of extraction. And what this is going to give you at a glance is the actual trace, right? The time that the entire trace ran. So whatever operations had to happen within that run in the application, you'll see that all here, given you go ahead and wire your application up correctly. So here we have a pain service. And so what we're trying to do is we're trying to extract a pain point and a service offering that would alleviate that pain from a particular Upwork job posting. And so you can see here, we won't go into too much detail here, but we have a job description. We are creating a social media marketing panel, so on, so forth. And then, okay, it's telling you what skills you need. And then of course, I'm just logging the raw prompt itself. So then we went ahead and sent that through an LLM, and we got the pain point. They want to efficiently create Facebook account login bots that can bypass Facebook's detection mechanism and save the logged in accounts with all the necessary data for further automation. So now this is their pain. This is what they're feeling. This is how what's their dream outcome. They want to be able to do something like this, right? They want to efficiently create Facebook account login bots. So if we can give them that dream outcome, and we can go ahead and lower the time that they can get those particular bots created, obviously they'll have higher satisfaction. So now you have a good idea of a service that you could potentially offer by just looking at the pain point, right? And of course you could do all this on your own, but we took it a step further here, and we actually had the LLM generate a service offering based on the pain point and the job description. So we have provide a comprehensive Python-based solution to create an anti-detect browser that can log into Facebook accounts with high efficiency, bypass detection, and save the account data for further automation. And so you can see just this simple extraction task can take this longer job posting, right? This longer job description, and it can extract what it infers as the pain that the actual job lister is experiencing, and then actually create a service offering that you can go out today. Someone's paying money for this actual problem to be solved, and you can attempt to solve it. And if you can't do that, then you can just try and do this on your own, and then now you have a valuable skill that you can potentially offer in the future. So we do that back and forth, right? So we have a lot of different data sets, data points here, and we just go ahead and infer those across this large data set. So you really do, at a glance, you get a latency for each one of these generations. So you can see this one completed in 1.21 seconds. Then you can see the actual tokens that this particular generation costs. So we have 1,038 input, 99 output. We can see the model. And then, of course, the most important, in my opinion, is the actual cost to run this inference. And you can see it's quite cost effective to run one. And you can see at a glance here at the top, for this entire trace, it's less than a cent. And so you can really get a lot of detailed information from this tracing system just at a glance, and then you can dive in deeper per each generation. So now I want to show you some additional things that Langfuse offers, which is this actual prompt library. Now, with the demo I'm going to show you later on in this particular video, I'm not going to use this per se, but you can see I've used this extensively for a lot of different generations in the past. And so the cool thing about utilizing this in its own as the LLM engineering system that it is that when you use the prompts, you can go ahead and get all of them tracked, all of the generations that are related to that prompt tracked in one place. And then you can filter as well. So let's see here. We had, if we go back to our prompts, we had this business value one. As you can see here, you have really nice version control. And again, depending on what you're doing, right? If this is your own personal project, maybe you decide to use this version control. If it's a client project and they have their prompts version controlled somewhere else, maybe you decide to do that. That's going to be based on your use case. But you do have that here out of the box. And in your code, you can go ahead and reference this one prompt name, and you can go to this dashboard and tweak the version and run evaluations on each different type of prompt, right? So you really get a good idea of how these are operating in a very, very quick and easy way. So we're gonna go back to the prompts, and we're gonna go ahead and look at the generations and all the filters that this has. So we can see here that we have all these. Now, what do we do with these? We're not sure. Let's go ahead and filter based on some type of error. So we're gonna go and find level. We're gonna say any of, and let's filter on error. You see down here, we have 110 pages. Let's filter on that. Okay, great. So we filtered on error. That brought us down to 13 pages now. So all of these are errors. And so maybe we're like, oh, we only use Claude Haiku. All these other experiments were just that experiment. So we're going to go to model. We're going to say any of, and we're going to find Claude Haiku. And here we go. Boom. And we have one of one. And you can see here now, we went from a lot of 100 plus pages to one page, and now we can see all of the Claude Haiku errors. And what's even cooler is you saw how we version controlled these. And so now we can even search by the version, right? So the specific prompt version, we're going to go equals, and let's go 4. Okay, so one thing that we don't see is how many actual prompts this is, or generations this is. So let's go ahead and filter this by 10. So we can see this is 10. 1, 2, 3, 4, 5, 6, 7, 8. There's 18 here. So 18 calls. And what you can do with this is you can drill down into these. So let's go ahead and open up one, and we can look at what the actual error was, assuming you log the errors, right? So log all your stuff. And then we can go ahead and say, okay, validation error, business value. Okay, it looks like it's a delimiter error. And we look here and it says join a legacy of 10. Okay, so we might come to some conclusions and say, well, Claude Haiku is usually pretty good. This is the same prompt version. Why are these all failing? Is there some commonality between these particular traces? And so then maybe we open up a few. We start to see there are cross trace IDs. So then we go here and we look, this one was overloaded. Okay, so that's seems like that's an error not in particular control. And you see what's interesting here is the name of this was wrong when I was logging it. So that could be part of the error as well. And so then you really get a good idea of what you did well and what you did wrong. And assuming you did everything well, then you can really drill down into the very specific errors that are plaguing your system. So I wanted to show you that. Next, I'm going to show you data sets. And we're going to take a brief look at this, but this is really for benchmarking. So maybe you have a golden data set and you already have some outputs that you already expect. You're going to go ahead and version your application. You made some changes, you changed the prompt, and we're going to go here. You saw here and you're like, okay, well, we have expected outputs. We have this golden data set. what you can do is you can go ahead and run some type of evaluation, like an exact match or even a slightly fuzzy match where you have some LLM as a judge. That's what we're going to show you today, but not in this particular fashion. And you can go ahead and evaluate and make sure that you're getting the score you expect across a data set. So you want specifically JSON output, and it just has to be JSON output. So you run all the ones you can get good JSON output for. You have a new prompt, you get that good JSON output, boom, it's good to go. Go ahead and release that application, right? That will be like one use case, but what we're going to show you today is something slightly different. And so let's just go ahead and jump right into that portion. So I have an application here, just a script. And so all this script is doing, it's rather long, so bear with me here. Let me just make sure here we got the pain score, pain service, eval set relevance. And so what we can actually do is we can clean this up, but no worries, we'll do that later. And this code will be in the description for you to play around with as well. And you can go ahead and clean it up and improve it. I just wanted to show you the functionalities here. So what we're going to do first is we're going to do all our normal imports. We're going to go ahead and define some Pydantic models. Here, we're going to go ahead and do some relevance evaluation to make sure that the pain point and the service offering that we extract are relevant to the job posting. Then, of course, we're going to go ahead and do something a bit new. We're going to go ahead and create data sets. And so we're going to create a good data set and a bad data set. And the reason why I put it in this way is because now you can start to isolate some of the edge cases into their own data set, and then on a separate note, you can start to run some type of experiments or evaluations to see if you can alleviate those, or you can get a good idea all in one place, all the bad outliers. And so you can do some examination to see how you can get to a state that's acceptable for your clients. So next, we're going to go ahead and create our typical run generations, right? This is just going to go ahead and run the actual generation. Now this is using instructor, and we're trying to get structured output. So we're going to do the typical create with completions. We're going to go ahead and run the compile prompt. We're going to get the usage out, and then we're going to end the generation. Next, we're going to go ahead and return this generation. And we should be doing an update here, but again, little things. I was just trying to show you this demo. So we're going to go ahead and create a run end eval. And so this is just going to run the evaluation. So the pain score and the service offering score. And finally, we're just going to go ahead and bring in a data set, and then we're going to run this application. And so here, we're just going to load in the prompts. We're going to run the generation. We're going to get the actual Langfuse generation back from the generation run. And we're going to go ahead and create our file or our prompt formats. Then we're going to go ahead and score each of these generations. And so in order to use this score function, you're going to need to name it, of course, and then you're going to have to pass it a value. So we're going to pass in the run end eval function that I created earlier. And again, that's just going to take a compiled prompt. It's going to take some input variables, a response model. This is going to be the pain score. And then we're going to run the second eval, the service score. And then we're going to go ahead and send those to the same trace that we're running all of our current applications with. And this is an example. You might want to decentralize these a bit, right, across whatever systems you're using. But just to give you an idea of how this all works. So if it passes, right, we're going to go ahead and add that to the good data set. And if it fails, we're going to add it to the bad data set. So let's just go ahead and see how this performs. We're going to run this. And eval 1, eval 2, eval 1, eval 2. All right, we should have one more, eval 2, and that's it. So we're only running through from the data set just to show you how it works. So we're going to go back to our dashboard. And in the dashboard, we're going to find data sets. And you see both of our data sets are created per the code. We're going to go to our good data. We're going to go to our items. And you can see here are the actual items in the data set. And now what you can do is you can consider these ones potentially golden, right? They at least gave you JSON output. And again, you want to evaluate what's golden and what's not based on your own criteria, your client's criteria. but ultimately you can put them in a data set and then you can run experiments on these when you upgrade your application later on. What I want to show you now is how we actually, on this particular trace, we went ahead and you can see here we have these scores here. So we can go down here and it's saying we got a 5 for the pain score and a 5 for the service score. So that's saying that it's highly relevant to the actual job posting itself. And so this is one way that you can run some ad hoc evaluations within Langfuse for experimental purposes, but ultimately this is supposed to be used for applications, and I'm using it slightly different here. So hopefully you learned something. Now, if you like what you saw, just go ahead and hit that subscribe button. Let me know what you thought about this video and what else you want to see. Hit the like button, hit the dislike button if you didn't think this was valuable to you. And of course, for everybody out there, I beg you, please, go build something. It's your boy B Phil. I'm out. Peace.